Here are some more examples. So these look a lot more complicated, but that's only because of the functions. So I look at this, 3/4 times the natural log of 1/3 of x plus 2 minus 7. Well, I hope you recognize that the function that this comes from is just the natural log of x. So what are the intercepts of this function? And I guess I'll call this f like that. Okay, so these functions, the intercepts of the natural log of x is the point 1, 0. So what happens to the point 1, 0? Well, the first thing that happens is a horizontal shift to the left of 2. So that would be negative 1, 0. Then a horizontal stretch by a factor of 3. So that would be negative 3, 0, because I multiply by 3. And then I take care of the y-coordinates. The y-coordinate would be stretched vertically by a factor of 3/4. Well, if I'm on the y-axis and I dilate through the y-axis, nothing is going to happen. 3/4 times 0 is 0. And then a vertical shift down by 7. So the new intercept would be negative 3, comma negative 7. What is the domain of my function f of x? Well, the domain of the original logarithm is 0 to infinity, not including 0. So let's see what happens there. Remember, these are x coordinates, so I only have to worry about the x. What happens is all of these get shifted to the left 2. So 0 gets shifted to the left 2. And like we said, if I shift an infinite number back 2, nothing's going to happen. And then we multiply by a factor of 3. It's going to be a horizontal expansion by a factor of 3, negative 6. And once again, if I pick any number and I multiply it, by 3, it's still going to be on the number line. So this is the new domain. What's the range? Well, the original range of the natural logarithm is all real numbers. So no matter what I do, I'm still going to wind up with all real numbers. The asymptotes are interesting. The original asymptote is the function x equals 0 for the natural log. For those that don't know what the graph of the natural log is, it looks something like that. This is the point 1, 0, and this is the asymptote x equals 0. So the question is, what happens over here? Well, x equals 0 only deals with the horizontal. So what happens, even though it's a vertical line, what happens when I take all these x values and I shift them to the left 2? 1, 2. Well, the new asymptote will be x equals negative 2. And then what happens when I dilate this by a factor of 3? In other words, here is my y-axis, and I'm going to stretch this by a factor of 3. This is going to be repelled 3 times away from this y-axis. I'm going to wind up with an asymptote of x equals negative 6. And that kind of makes sense when you look at where the new intercept is. The new intercept is at negative 3, comma negative 7. And the new vertical asymptote is x equals negative 6. This is twice the x-coordinate of negative 3. That kind of makes sense because here I've got only 1, a distance of 1. Here I've shifted this two spaces to the left, and then I've stretched it by a factor of 3. Hence the distance now of twice as far away. So intuitively, that kind of makes some kind of sense. And if you actually graph this in a graphing calculator, you'd see. Write 2 other points. All right, what other points are on ln of x? Well, the point e comma 1 is on there, and the point e squared comma 2. No one ever said we couldn't use e. E is a number. So let's see. A shift to the left 2 would make e minus 2 comma 1. And then multiply that by 3 for the vertical stretch. That's 3e minus 6 comma 1. Sorry, horizontal stretch. The vertical stretch is by a factor of 3/4. 3e minus 6 comma 3/4. And then a vertical shift down 7. So that would be 3e minus 6. And then I have to subtract 7 from 3/4. That would be, let's see. If I subtract 7, that's minus 28/4. That would be negative 25/4. And there is my new point. E squared comma 2, same game. I'm shifting to the left 2. That's e squared minus 2 comma 2. Horizontal stretch by a factor of 3. 3e squared minus 6. Again, not surprising that these 2's are becoming 6's. a vertical stretch, or in this case compression, by a factor of 3/4, because that's less than 1. So 2 times 3/4 would be 6/4, or 3/2. And then a shift down 7. 3 minus 14 is negative 11. So this would be negative 11/2. And there is my new point. These are just numbers. That's how to deal with asymptotes and unfamiliar functions. This one's really tricky. This comes from the function f of x equals 1 over x. And this one's tricky because of the 3 that's up here. So what I'm going to do is I'm going to rewrite this. This is the same thing as 1 over 4/3 x plus 1 plus 2. And when I rewrite it that way, now here's my 1 over, and then this is all the stuff in the bottom I'm doing to the x, and then this plus 2 is what I'm doing to the y. So now this is a little easier to kind of deal with. So first, what are the intercepts of this graph? Well, what are the intercepts of 1 over x? 1 over x didn't have any intercepts, did it? So what happens to the intercepts here? Well, the intercepts, they would just move. I mean, there's no place for them to move. So where do the intercepts move? Oh, and this shouldn't say write the intercepts. This should say write basically where the intercepts go. Whoops. Where the intercepts go. I want to know where those points actually are. To find the intercepts, I could just set this equal to 0 and plug in 0. I meant where do they go? Well, there are no intercepts, so there's nowhere for them to go. So write down where the intercepts go. They don't go anywhere because there are none. So there were no intercepts. What is the domain of f of x? Well, the domain of the original is all real numbers except for 0. So that's x such that x does not equal 0. So what I need to do here is I just need to shift and stretch this value of x equals 0. So the first thing we need to do is shift it to the left 1, x such that x does not equal negative 1. No. See, that's a common mistake. No, 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 no. 4/3 x plus 4/3 plus 2. Now it's in the form we want. You see, this is not the form we want. We have to do a shift first and then a horizontal stretch. So we need it to be in the form ax plus b, or I believe in the other thing it was bx plus k. So horizontal shift 4/3, horizontal compression by a factor of 4/3. That means I have to divide by 4/3. So this domain is going to go to x such that x does not equal negative 4/3 divided by 4/3, negative 1. What's the range? Well, the original range was everything except for 0. I mean, if you remember what 1 over x looks like when it's graphed, x equals 0 and y equals 0. Here's x equals 0, y equals 0. We're asymptotes, so there wasn't defined there. So we play the same game. There's no vertical stretch or compression, just adding 2. So y such that y cannot be 2. And there's your new range. Here's your new domain. What are the asymptotes of this thing? Well, that one's easy enough. Let's take the original asymptotes and let's see what happens to them. So the original asymptotes were x equals 0 and y equals 0. So for x equals 0, same game as we just did for the domain. I only have to deal with what happens to the x values because x equals 0 is this vertical line. It only deals with x values. So the first thing that happens is x gets moved to the left 4/3, and then it gets compressed by a factor of 4/3. There's your new asymptote. Y equals 0, you can imagine, same thing is going to happen as what happened to the domain. All we're doing is shifting 2 up. So this y equals 0 gets shifted up to y equals 2. What 2 points? All right, well, I know that the point 1, 1 is on it. I know that the point negative 1/4, comma negative 4 was on the original. So let's see what happens. 1, comma 1. So we have a horizontal shift to the left of 4/3. That would be negative 1/3, comma 1. And then a horizontal compression by a factor of 4/3. So negative 1/3 divided by 4/3 is negative 1/4. Oops. Negative 1/4, comma 1. And now I deal with the y coordinates. The only thing that's happening there is a vertical shift of 2. Negative 1/4, comma 3. Here we have negative 1/4, negative 4. Same game. I'm shifting to the left by a factor of 4/3. So that means this is going to be negative 1/4 minus 4/3. Whatever the heck that is. What is that? That is the same thing as, this would be 3/12. This would be 9/12. Negative 12/12. Negative 1. Really? Negative 1/4 minus 4/3 is negative 1? That's not right. Negative 1/4 is 3/12. Negative 4/3 is 16/12. There we go. I was going to say that's negative 19/12, comma negative 4. We shifted to the left 4/3. And 1/4 minus 4/3 is the same thing as negative 3/12 minus 16/12, which is the same thing as negative 19/12. Then I've got to divide by this 4/3. So 19/12 divided by 4/3 is the same thing as 19/12 times 3/4. And that would be negative 19 over 16, I believe. And then it's just a vertical shift up of 2. Negative 19 over 16, comma negative 2. And there are my 2 new points. And it really is just that simple. So I'm going to correct the typos that I have on here. I don't want you to find the intercepts on this. I want you to find where the intercepts move to. So that's a typo I've got to fix. Now you can do the assignment. And then that will be it as far as curve shifting is concerned. And as always, this gets the Cetron seal of approval.